Assalamu alaikum, bacho. I'm going to tell you how to find this maximum angle over here up to which we can rotate this this inclined plane over here so that this does not topple over here. Okay, I have shown you some diagrams over here. This is the initial situation here. This cuboid is resting on a horizontal platform here. Okay, and um, right now obviously this will not topple here. This is comfortably in an equilibrium situation here. So when we start rotating this platform up here, like you see, this is the first situation, first condition here. We have rotated this up to theta 1, and let me erase this over here, and here we have rotated this up to theta 2. So we have to see that up to what angle we can rotate this platform so that this cuboid does not topple over here. Okay? Now, while we are doing this, we should be informed about one thing, that there is an enough friction between this block and the surface that we are not worried about sliding of this block over the surface. Okay, so whatever is this angle of inclination over here, this block will not be sliding down. So that is for sure, that is understood thing. So now we have to determine that if how much we can rotate this up here so that this does not topple here. Okay, acha. uh, mm, to determine that, we need to know that this weight is always directed towards the center of the earth. So this is always a vertical line here. So you can see this red line showing where the weight is going, how this weight is acting. Okay, now here is this is the point here, when this line of weight is passing through this vertex C over here. Okay, and if I slide this a bit up, you will see that this weight line is going to pass through an area which is outside this block over here. So for this situation, the block should have toppled. Like imagine if I move this up like this, okay, and the block is like here. Is it possible that I slide this up to this and this still remains here? Is it possible, guys? Hmm?
No, no.
Not at all, because the weight is acting in this direction. Okay, so as long as this direction of the weight remains inside this region here, this block will not be toppling. And right now here, this is the point where it is about to topple here. This is about to topple here. Okay, now we shall be using our mathematics to determine that what is this angle up to which we can rotate this. For this, you have to imagine that, okay, here was actually, this is your, like, you know, this is the center of mass is exactly in the middle of this block here. So if this is A, so this much is going to be A over here up to this. Okay, so this is in this diagram, you can see that this is A over here. This is your theta. And when this was, all of this was A, so then, you know, this is going to be half A, this is going to be half A. If this is your theta 2 over here, you must be able to say that this is going to be theta 2 as well. Okay, so in general, as you people have seen in those typical diagrams, when you people are determining the component of the weight, for example, here is a block, whatever, you know, if this is, its weight is like this mg over here. So remember, you people have been doing it like this is to determine r, and this is, you know, the weights components like this. If this is theta, here is a right angle, this is 90 minus theta, so this is going to be theta over here. And you know, this is your mg cos theta, this is your mg. You have, you people do this a lot in your A level mechanics. Okay, acha, so we now know that this angle is same as this angle over here. Okay, so to determine this angle, we're going to use this diagram. So this is your theta over here, the angle that we have to find. You know that this is your A and this is your A over 2. And using this relation over here, that tan theta is going to be opposite over adjacent, you get this half, and it says the block topples when your theta is going to be 26.6 degrees. Okay, because it is the point, this is the point when it is going to be about to topple over here. Okay, so here's the next question. A solid uniform hemisphere is placed on a rough slope with its plane face against the slope. Assuming the friction force is great enough to prevent the hemisphere from slipping, if the slope is inclined at an angle of 65 degrees, state whether or not the hemisphere topples. Justify your answer. If it does not topple, what is the maximum possible angle of inclination of slope? Okay, now you people have to forget this given angle over here, and let's make our own diagram. Suppose here is that inclined surface, okay, and here is the theta, and here is our hemisphere. Okay, remember, where do we have, like, if you have normally a hemisphere, so where is the center of the mass for, like, if this is O, this is G, so how much is this OG? If the radius is R, yes, come on. I
2R sine
I
theta
think that
over
is 3
3R.
over 8 R. I think that was 3
Oh,
over 8 R. That is
yes.
2R sine alpha over 3 alpha. That is, I think, for the sector. है ना? This is for the sector
Yeah.
with the angle 2 alpha. है ना? This is for the sector with the angle 2 alpha. अच्छा बच्चों. So we have this 3 over 8 R over here. Acha. It says what is the radius given? Let me read. Solid, assume the friction, the slope is, justify your answer. Okay, so we have to assume that the radius is R. The radius is not given, and I have to assume that its weight is going to be mg over here. Okay, the weight is mg. Acha. Now, suppose I am going to slide this in a way, like, let me keep it like this. Here is that, okay, and here is, so let me draw this again. Just 1 second. Oh, come on, it has to be in white. Okay. Um, I want this to be drawn in a way. Here is that hemisphere, and here is the center of the mass. So it is going to pass through this, okay? So here is the theta. This is your mg, and this much over here is 3 over 8 r, and this is your r over here. Okay, so let's find what is this theta, what can be this theta. So this is the angle at which this is supposed to topple. Okay, so this is going to be tan theta r over 3 over 8 r. Can you quickly tell me what would be the, if, like, if I simplify this, I have tan theta equal to 8 over 3. Can you please use your calculator and tell me what is going to be this theta? So this is 69.4 degrees here. So this means if you have rotated this up to an angle of 65 degrees, so would it topple or not? Hmm?
Or not.
It will not, है ना? And it will be toppling when you reach at this angle. Let's see how he has done this. Okay, let me slide this up. Let's check the answer quickly. Yeah, that is your 69.4 degrees over here. Okay, guys, now you have to try this question. In the meanwhile, I want to finish my cup of tea. Okay, I'm just going to cover this. You people try this. Okay, chale. Acha, a shape is formed by joining a solid uniform cylinder to a solid uniform cone. Okay. The cylinder has radius r and height r. Okay. So, okay, I have drawn this a bit wrong. I should cover this like this. Oh, it should be covered with white. Okay. So we have the cylinder's base radius is r and its height is r as well. Okay. So this much is r, and this much is r. This much is r. Okay, and it says and the cone has a base radius r and height 2r. Oh, so this should be erased as well. I have drawn this a bit wrong here. Okay, so this should go up to this. Okay, so this height is 2r over here, and the radius is r. Okay, so the two solids are joined by a plane face, and the line of symmetry of the two solids coincide. Okay, so this is the line of symmetry basically over here. This shape is placed on a rough slope as shown this. If the slope is sufficiently rough to prevent sliding, find the angle at which the shape is about to topple. Actually, the thing is, we need to know that if, for example, if I draw like, the weight from down from here like this is the weight. So I need to know that how much is this distance, that is the center of mass. Where is the center of mass acting? So I have to find it from, like, if I keep this as x, I have to find this x from here. Okay, na? So we know that this is going to be r by 2. So the only mission is to find this x, and you will be easily able to find this theta
No,
over here.
that would be R. It would not be R by 2 because radius is R.
Oh, thank you, thank you, thank you, thank you. This is R. Thank you very much. I just, by mistake, I wrote that R. Okay, thank you, beta. Acha, bachcho. Now, let us find using the moments. Just keep it on the flat surface, and I'm going to find from this point. Let me call this point O. I'll be finding that from this point O. Okay, and I already know that the cone's center of mass is at 3 over 4 h. So this is 3 over 4 of 2r, that is going to be 3 over 2r. So this length is going to be 3 over 2r. And we know that this since this is a uniform shape, this cylinder, so its center of mass would be at the center. Okay, so that I can say this is going to be r by 2 over here. Okay, and from this O, this is going to be 2r plus r by 2. That is, if I keep this point as G here, and I keep this point as M here, okay? And I have to find this point N over here, which is going to be the center of mass of the whole solid here. We are not sure if N is going to be above M or below M, okay? So I'm just assume that this N is over here. I think this would be above M because the cone is at the top here. Okay, so uh, first of all, we must be knowing the volumes here. The volume of cylinder is going to be pi r square h. So this is going to be pi r square h, pi r cube, है ना? Pi r cube. Therefore, its mass of cylinder is going to be pi r cube rho. Similarly, the volume of cone is going to be 1 over 3 pi r square h. 1 over 3 pi r square h. So that is going to be 2 over 3 pi r cube. And the mass of this cone is going to be 2 over 3 pi r cube rho. And then you should know the total mass as well, okay? The total mass is going to be pi r cube rho 2 over 3. Is that going to be 5 over 3? Hmm? Pi r cube rho. Yes, bacho? Yes? Okay. So,
Yes.
yes, okay. Now, this is going to be 3 over 2r into 2 over 3 pi r cube rho. That is for the cone. Plus, from this, I think I have already determined that 2r plus r over 2, that is going to be 5 over 2r. That is for the cylinder. 5 over 2r times pi r cube rho, that is equal to the total mass. Now this, I want to find this x. Let me keep this distance x over here, okay? So that is going to be x into 5 over 3 pi r cube rho. Okay, so this pi r cube rho, pi r cube rho, pi r cube rho is cancelled out here, and this is cancelled by this is cancelled by this. So we have r plus 5 over 2r. That is going to be 7 over 2r. Yes, 7 over 2r times 3 over 5. That is your x. है So this is going to be 21 over 10. So x is going to be 2.1 r. 2.1 r. Is that right? So this is quite right. So now we have got that this distance over here, let me make it a bit bold here. This distance is going to be 2.1 r here, okay? So that means this distance over here is going to be zero point 0.9 r because this was all 3 r. And if you take out 2.1 from this, so this distance is left as zero point 0.9 r. Now the thing is quite clear. We can simply use the trigonometry over here, okay? And we can say, okay, from this diagram, um, this tan theta is going to be r over zero point 0.9 r, है ना? So now please find that theta. So this is the angle at which if you move it up to this, so this solid will topple if you reach the angle of 48 degrees. Acha, now we have some fight here. So I'm going to end this here, and in the next segment we shall move into the sliding cases, inshallah.